This is part D for question 5. Calculating distance if x, which is spring constant, is equal to the value determined in part C. So as you can see, that's what's going on. The reason why our our displacement is so large is because from the previous video, the spring constant was so low, and that makes that number, okay? So but now we're just gonna go ahead and use whatever the value we have. Don't mind about some other thing, but just go ahead and follow the steps. So that's a compress, right? And this box right here is being compressed on the table. And now you have the box which has the same mass. M is equal to 1 kilograms. That's what it is. It's M2. M1 is 1 kilogram. So because basically what the question was saying was, mass 1 and mass 2 is equal. So now you're gonna have to figure out what happened when there is a collision in this one. But then the question is actually telling you that after collisions, both blocks sticks together. So you're gonna have to show the picture that they actually sticks together. So I'm just gonna say this is initially at rest, and after collisions, it will go and it will travel this way, and it land here. So we want to figure out, the distance in the x direction. So I'm just gonna go ahead and determine d, which is delta x. Okay. So with this one, you're gonna have to use the concept of conservation of energy first to figure out the initial velocity. There are multiple parts to this problem. So I'm just gonna use this one. Spring is equal to kinetic energy. So that would be 1/2 kx squared is equal to 1/2 mv squared. And now we're gonna solve for velocity. We get rid of this one right here. So that would makes it velocity is equal to square root kx squared divided by m. So now you can just gonna go ahead and replace the values. What's my k? 10. What's my x? 3.35 square. Mass is m. Whatever the answer you have, they will tell you what the value of the initial the velocity after the spring is pushed is. The answer, it makes it this much. So I'm just gonna say it's 10.959 meter per second, and that's the initial velocity. So now what we will do is we will go ahead and this one right here is moving at velocity of meter per second, and then eventually it collides with this mass right here, which has velocity of 0. So after collisions, they both stick with the same velocity. That's what we're looking for. So now we want to go ahead and figure out m2 times v2 is equal to m1 plus m2 vf because that's inelastic. Sticks together. So m1 is 1 times velocity 1 plus 0 because this is an initial at rest. To VF. My VF is equal to divided by 2. So the VF is equal to this 5.3 second. That's what you will get. So the third part is that, we use kinematics equation. So what we will do is we will utilize this to figure out the time it takes from here to here first before we can figure out what the distance in the x direction is. 5 time. So my height, I believe the question says that the height is equal to 10 meters. So I'm going to put 10 there. 1/2 10t square. T is equal to square root of 2, which is, I'm just going to put it that way. T is square root of 2. Then use 2 phi d is Vox times t. Initial velocity, which is the one we just got from here, so that would be 5.3 times square root of 2, and that should give you a distance. So your distance right here, which is delta x, basically, it's the same thing. It's equal to that times square root of 2, and that should give me the answer of 7.5 meters. So this is your answers. This is your answers. This is your answer. So you should have 3 more parts of the answer in order for you to figure out what this is. As you can see, the question 5 part D is very complicated and it takes a lot of time. So this question will definitely be on your test and your AP exam.